In this lesson, our goal is to get comfortable with fractions. Specifically, we'll understand fractions, we'll learn to simplify fractions, multiply and divide fractions, write improper fractions as mixed numbers and the other way around, and then we'll solve a couple application problems involving fractions. First, let's talk about the number line. So when we draw a number line, we typically draw something like this. We have 0, 1, 2, 3, so on, -1, -2, -3, and so on. So what's falling between the integers? Because we know we don't just have 0, 1, 2, 3, and so on as numbers. Between our integers, we have fractions. Some fractions can be written as decimals, or we have some decimals that can't be written as fractions. We'll talk about that more in the next lesson. But think about first in between like 0 and 1. In between 0 and 1, you could have things like a fourth or a quarter, a half, 3/4, 5/8, so on and so forth. So fractions are a part of our numbers that are in between our whole numbers, and this number line is designed just to give you a visual as to where these numbers are coming from. So let's talk about fractions. So fractions come in the form of a over b, where a is our numerator, and b is the denominator. Okay, so the number on top is the numerator, the number on bottom is the denominator. That fraction bar that you see means division. So fractions can really be written also as a divided by b, and that will be helpful when you're doing any type of calculations, remembering that the fraction bar means division. And what fractions are equal parts to a whole. So the denominator tells you how many equal parts to make out of the whole, and the numerator is talking about how many of those you're dealing with or talking about or want or representing. So some common examples of fractions: a cent is 1/100th of a dollar. A quarter in money is 1/4 of a dollar. So if you break a dollar up into 4 equal parts, you get quarters. And if you're talking about one of those, you have 1/4. Same thing in sports. With football or basketball, a quarter of the game is 1/4 of the whole game. Okay. Another note on fractions is whole numbers can be written as fractions. You put them over 1. So if you're talking about the number 7, this can be written as 7/1 to write it as a fraction, which might come in handy when you're doing some calculations with fractions. Okay. So first, let's visualize a couple of these. Make as many visual representations as possible of 3/4. So with this, the 4 tells us how many equal parts we're going to have. We're going to divide the whole into, and then 3 is how many we're actually talking about. Okay, so for instance, if you have a circle, we would divide it into 4 equal parts because the denominator is 4, and then that 3 means we're dealing with 3 of those parts. So the green represents 3/4. You could have other shapes. I'm not very creative, so I'll stick to my circle and rectangle, but you might think of something else as well that you can use to represent 3/4. So again, talking about 3, pretend those are all equal parts. So this would be a visual representation of 3/4 as well. Okay, so next we're going to talk about simplifying fractions. So just a note about simplifying fractions. When you're simplifying a fraction, you're making an equivalent fraction that's as small as possible. So one note on equivalent fractions: 5/10 is the same as 1/2. The reason why is 5 is half of 10, 1 is half of 2, or you may remember from a previous class that if you divide 5 by 5, you'd get 1, and if you divide 10 by 5, you'd get 2. So that's also why it's an equivalent fraction, is if you divide or multiply the numerator and denominator by the same number, the resulting fraction is equivalent to the first fraction that you have, and you could draw a visual representation of this as well. So let's say I have something that was broken into Okay, so that has 10 parts, and I'll draw the same thing that's broken into 2 parts. Okay, so 5/10 would be 1, 2, 3, 4, 5. 1/2 would be this. They would be visually the same as well. So that's just another way that you can think about these fractions. Okay, so when you're simplifying fractions, you're making an equivalent fraction, meaning you're multiplying or dividing the numerator denominator by the same number, typically dividing if we're going smaller, and then you know that it's completely simplified when the numerator and denominator or top and bottom have no other common factors. Okay, so a couple of examples of this. So what I'm going to do is I'm going to do these by hand, and then I'm going to show a slide as to what buttons you would use on your calculator to do these. And so I'll emphasize again, but make sure you go back through these examples, using your calculator. And if your calculator is coming out with something different, let me know so I can help you with that. Okay. So write the fraction in lowest terms or simplify, those mean the same thing. So what you'll do is you'll look for common factors in the numerator and denominator. So in part A, since 10 ends in a 0 and 25 ends in a 5, they both have a common factor of 5. So I'm going to divide each by 5. So this is equal 10 divided by 5 is 2, 25 divided by 5 is 5. My resulting fraction is 2/5, and they have no common factors other than 1. So that's how I know it's simplified all the way. For part B, 7 and 49, 7 goes into 49 itself, so you would divide by 7. 7 divided by 7 is 1, not 0. There's a 1 there. 49 divided by 7 is 7. Okay. And then for part C, if you can't think of a number that divides into both of them, these are big numbers, start with something small. 256 and 128 are even, and so with even numbers, they're both divisible by 2. So we'll start dividing each of these numbers by 2. So 256 divided by 2, 128 divided by 2. This gives us 128 over 64, and then you can keep going if you want, or you may see it right away. But there's nothing wrong with starting small and then working your way down. 64 over 32. In this case, I know that 64 is divisible perfectly by 32. So this final answer here would just be 2. Next, multiplying and dividing fractions. So when you're multiplying fractions, you go straight across the numerator, multiply those together, multiply the denominators together. And the rule with dividing fractions is you keep the first fraction the same, you change the sign from division to multiplication, and you flip or interchange the second fraction. So first example, multiplying fractions. With multiplication, we go straight across. So when we have 2/3 times 1 over 7, this becomes 2 times 1 over 3 times 7. 2 times 1 is just 2, 3 times 7 is 21, and then the instructions say to simplify. 2 and 21 don't have any other common factors, so this is the final answer. Part B, even when you have 3 fractions, you use the same principle. So we would multiply across the numerators, 5 times 3 times 1, and multiply our denominators together. 5 times 3 times 1 is 15. 8 times 2 times 4 is 64. So our final answer is 15 over 64. With dividing fractions, you keep the first fraction, you change the sign to multiplication, and then you flip the second fraction. So what that looks like is 1/2, change the sign to multiplication, and then interchange the numerator and denominator of the second fraction. And now it's multiplication, what we just worked with. So 1 times 8 is just 8, 2 times 7 is 14. Both of these are even, so you can simplify them to get a final answer of 4 over 7. Okay, part B, we have 12 over 7 divided by 6. This is where maybe writing 6 as a fraction by putting it over 1 may come in handy so that you're dealing with 2 fractions. So we keep the first fraction, change the sign to multiplication, and interchange the numerator and denominator on the second fraction. So this is 12 over 42, and then again you would divide by whatever number you see. You could even divide them both by 6. Let's do that to get 2 over 7 as a final answer. Next, what we'll talk about lastly before we get into our application problems are improper fractions and mixed numbers. So improper fractions are fractions where the numerator is bigger or greater than the denominator, and mixed numbers contain an integer and a proper fraction with them together. Okay, so things like 1.5 would be a mixed number. So in order to convert improper fractions to mixed numbers, we'll use division. And so you could see the instructions as convert to a mixed number or write the improper fraction as a mixed number. So with 22 over 7, the 22 is greater than 7. And so what we'll need to do is, since a mixed number is an integer, which are positive and negative whole numbers, and a proper fraction, we'll need to find out how many times 7 goes into 22, and then what's left over will become our fraction. Okay, so we'll use division, so we'll take 22 divided by 7. Okay, it goes in 3 times. 7 times 2 is 14, times 3 is 21. Okay? And then if you remember long division, you take 3 times 7. This gives us 21. Subtract, and we have a remainder of 1. So in order to write this as a mixed number, 3 is our whole number, or our integer. It's positive 3. And then our fraction, we had 1 left over, but remember the whole was divided into 7 parts. So this is 3 and 1/7, which also means 3 plus 1 over 7. Okay? So 3 and 1/7 is the final answer here. We'll do the same for part B. So this number that we get is ultimately going to be negative, but when you're working with the division, you're working on 34 divided by 8. 8 goes into 34 4 times, and then we subtract. So 34 minus 32 is 2, and we apply the same thing here where we would have 4, and it's negative from the negative up above. And then you can simplify this 2 over 8 by dividing each by 2. So our final answer here is negative 4 and 1/4. Okay. So going the other way around, keep this in mind. We're going to write the mixed number as a fraction and show. So what I'm going to do is show you what's happening with these, and then I'll show you how to do them quickly. So 4 and 1/3 really means 4 plus 1/3. So 4 wholes and then plus another third gets us 4 1/3. Okay. We didn't really talk about adding and subtracting fractions, but to do that you need a common denominator. So I put this over 1 and I'm going to multiply to get a common denominator. I'm going to multiply the top and bottom by 3. So this gives me 12 over 3 plus 1/3, which is 13 over 3. Okay, so that's kind of what's going on. But what you can do for these is you can take the denominator times the whole number, so 4 times 3, add the numerator of the proper fraction, and then put it all over 3. So 4 times 3 is 12, plus 1 is 13 over 3. So you get the same answer either way, but I just wanted to show you what's going on. Okay, similar is part B, so we would take, so it's going to be negative. We would do 8 times 6 plus 5 times add, and then divided by 8. So this turns out to be 6 times 8 is 48. So this would be negative 53 over 8. Okay. All right, and so here's the screen. Take a picture of this, write it down. The 2 calculators in the syllabus are the Texas Instruments and the Casio. So I've given you the buttons to push on each of them, and really go back through these examples because remember, you can use your calculator on the test. And so make sure you know how to use it. And if you're having any trouble, be sure to visit me in my office hours so I can help you with that. All right, so lastly, we'll do a couple of application problems, and I'll show you a couple of different ways to do each of these. Leo farms 864 acres of land. One year he planted soybeans on 7/16 of his land. How many acres did he plant with soybeans? So first I'm going to do a visual, and then we're just going to do some arithmetic with the whole number and fraction that we're given. So remember, this 7/16 is equal parts to a whole, and so we're dividing the land into 16 equal parts. Okay, but the total of the land, so I'm going to do it like this. This whole thing is 864. We're going to divide it into 16 equal parts, but we need to see how many acres are in each part. So to do that, we take 864 divided by 16, which gives us 54. Okay, so there's 54. Oh, I'm missing one. This isn't 16. There we go. Okay, so we have 16 equal, use your creative imagination, 16 equal parts, each having 54 acres. If you take all of these 54s and add them up, you will get back to 864. So we've taken the total amount of land. I pictured a square. I guess you could have pictured a circle or a rectangle, whatever, but we divide it into 16 equal parts, which means there's 54 acres in each part. Okay. Leo is planting on 7 of them. So take 7, 1, 2, 3, 4, 5, 6, 7. And so the purple represents how many acres or where he's planted these soybeans. So you would take 54, 4, 5, 6, 7, and this would get you to 378 acres. Okay. It makes sense too because he's planting on a little bit less than half. The other way you could do this, and you might have seen it right away, let me do it in green. You could have taken 864 and you're planting on 7/16 of the land, so 7/16 of 64, so you could multiply as well. Okay. Next, if the President of the United States vetoes a bill, at least 2/3 voting members in the House of Representatives and at least 2/3 of members voting in the Senate must vote to override the veto for it to become a law anyway. If all 435 members of the House vote and all 100 members of the Senate vote, how many votes are required in the House and Senate to override a veto? So with the House, I'll use the visual representation, and with the Senate, I'll do the mathematical calculation. So with the House, we have 435 members, so I'm just going to use a rectangle. This is 435. We're talking 2/3 need to vote to override the veto. Okay, so we divide this into 3. So we take 435 and divide by 3 to get 145. Okay, and again, if you add up 145, 3 times you'll get to 435. 2/3 of those would be 145 plus 145, which is 290. So to override a veto, 290 votes in the House are required. Okay, for the Senate, I'll do it the calculation way, 2/3 of 100, so we would take 100 and multiply by 2/3. This turns out to be, if we do it in the calculator, this turns out to be 66.667. Okay, so the rounding here is really important. I know this number is closer to 67 anyway, but even if it was 66.1, you would still have to have 67 votes because you're required to have at least 2/3. So anything below 66.67 is not okay. Or just for illustration, even if it was 66.1, that's not going below that is not an at least. Okay, so 67 votes in the Senate are required. Thank you for watching. If you have any additional questions, please feel free to reach out to me.